Now let's divide x cubed minus 126 by x minus 5. Then, let's go ahead and divide x cubed minus 126 by x minus 5. And once we find our answer, let's label the quotient, the divisor, and remainder if possible. Starting off, we have x minus 5 is dividing into our x cubed minus 126. And first we want to get rid of our x cubed, so we want to multiply x minus 5 by an x squared. Multiplying this, we'll get an x cubed minus a 5x squared. Multiplying this by negative 1 and adding it to the top term, our x cubes cancel out, and we're left with a positive 5x squared. Now go ahead and pull down the negative 126, and we're going to repeat this process now. We need to go ahead and multiply our x minus 5 by a 5x, and this is going to become a 5x squared minus 25x. Again, multiply this by negative 1 and add it to the top term. Our 5x squared is canceled out, and we're left with a 25x minus 126. In this last step, we want to multiply x minus 5 by a 25. This is going to give us 25x minus a 125. Multiply this by a negative 1 and simplify. The 25x's cancel out, and we're left with just 1. Since the term 1 here has degree less than our x minus 5, our algorithm is going to go ahead and stop. Therefore, we can rewrite our x cubed minus 126 to be the following. This is going to be equal to x minus 5 times x squared plus 5x plus 25 plus 1 divided by x minus 5. And here, this is our quotient. This term here is the remainder. And our x minus 5, the divisor. Let's look at one more division algorithm problem. We want to go ahead and divide x to the fourth minus 3x squared plus 1 by an x minus 1. Rewriting this using our normal notation, this is going to be x minus 1 divides into x to the fourth minus 3x squared plus 1. To get rid of our x to the fourth, we need to multiply x minus 1 by an x cubed. This is going to give us a x to the fourth minus x raised to the third. Multiplying this by negative 1 and adding it, our x to the fourth cancel out, and we're left with an x raised to the third. Pull down the negative 3x squared. Now we want to go ahead and get rid of this x cubed, so we want to multiply our x minus 1 by x squared. This leaves us with x cubed minus an x squared. Multiply this by a negative 1 and then add it to the top. Our x cubes cancel out, and we're left with a negative 3x squared plus x squared, which is a negative 2x squared. Now go ahead and pull the 1 down. And we want to get rid of the negative 2x squared, so we're going to multiply our x minus 1 by a negative 2x. This becomes a negative 2x squared plus 2x. Multiply this by negative 1 and simplify. So the negative 2x squareds cancel out, and we're left with a negative 2x plus 1. And now we want to get rid of the negative 2x, so multiply our x minus 1 by the negative 2. And then add this to the top, and we're going to get our negative 2x's cancel out, and we'll get a 1 minus 2, which leaves us with a negative 1. Now, since the degree of our negative 1 is less than the degree of x minus 1, the division algorithm is complete. And the answer we get when we divide x to the fourth minus 3x squared plus 1 by x minus 1 is going to be equal to an x cubed plus x squared minus 2x minus 2 with the remainder of a negative 1 divided by x minus 1. We can go ahead and rewrite this using the quotient, remainder, and divisor language, and this is going to be equal to the following. Here, x to the fourth minus 3x squared plus 1 is equal to x minus 1, this is the divisor, times x cubed plus x squared plus 2x plus 2. This is our quotient, plus a negative 1, which is our remainder. Oops, I just realized I made a mistake in the quotient. This actually should have been an x raised to the third plus x squared minus 2x minus 2. In this final problem, we want to determine if x minus 2 is a factor of 4x to the fourth minus 15x minus 4. In the book, it asks us to use synthetic division, but this is unnecessary. The fact that we'll be using instead is the following. A factor x minus c is a factor of f of x if and only if f evaluated at c is equal to 0. In other words, x minus c is a factor if only if c is a 0 of our polynomial f of x. If we set f of x equal to a 4x to the fourth minus 15x minus 14, then x minus 2 is a factor of f of x if and only if f evaluated at 2 is equal to 0. So we just need to evaluate f at 2. This is going to be equal to 4 times 2 raised to the fourth minus 15 times 2 minus 14. Simplifying this, this is going to be 4 times 16 minus 30 minus 4. This is equal to 64 minus 30 minus 4, which is equal to 30. So this is not 0. And what this tells us then is that x minus 2 is not a factor.